This tutorial is meant to help you understand how the energy levels or rings around the Bohr model diagram are related to the periodic table rows. So the first thing I want us to go back over is just understanding energy levels. Bohr's idea was that electrons existed in energy levels. And so the ones closest to the nucleus, the energy level 1, those electrons contain the least amount of energy. And then energy level 2, they have a little bit more energy. Energy level 3, increasing amounts of energy as you go away from the nucleus. Okay, so part of what you're supposed to do in 9th grade, or what you're expected to do in 9th grade, is to be able to draw a Bohr model diagram and to relate that diagram to the number of valence electrons that each element on the periodic table actually has. The periodic table is laid out in a way that is correlated to those energy levels on the Bohr model diagram. If we're looking at row 1, and we can see that in row 1 there are 2 electrons, one from hydrogen and then one from helium. And the Bohr model diagram, energy level 1, can only hold 2 electrons. That's where they come from. In the second energy level, or the second row on the periodic table, if we count as we go across, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons in that row. Energy level 3 in the third row has 1, 2, 3, 4, 5, 6, 7, 8. And again, we're trying to figure out how to fill out these electrons, trying to make it a little bit easier. Row 4 is a little bit trickier because in row 4 we have these 2 electrons here from potassium and calcium, but then as we're going across the row we get into the transition metals, and so we actually have to go back into the third energy level and add 10 electrons because there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in that row. And so we have to add 10 electrons to the third energy level before we can move back into the fourth row and start adding our remaining electrons there. Same kind of trick happens in the fifth row. In the fifth row we can add the 2 electrons from rubidium and strontium, but then we have to jump back down to the fourth energy level and add up to an additional 10 electrons before going back to the fifth energy level and finishing that out with 6 additional electrons. And it keeps kind of going on that way. For 9th grade, we're going to kind of stop there. Those of you who want to do some more advanced work, we will get into the F block, but we'll refer back to that chart that we had drawn earlier in class with the 2 electrons, 6 electrons, 10 electrons with the arrows. So now let's put that information to use. Okay, so we're going to zoom in on our model down here, and we're going to just do a couple of examples in those upper regions. Let's say we were assigned magnesium, and we had to write the Bohr model diagram for magnesium. So I'm going to use this chart. I'm going to know that in that first energy level, that first row, I have 2 total electrons. So I'm going to add my 2 electrons to that first energy level. Looking now to the second energy level, I can see that I have a total of 8 electrons in that energy level. So I'm going to add my 8 dots to the second ring. So 1, 2, 3, 4, 5, 6, 7, 8. Now I'm in the third energy level, so I'm right in here. I only have 2 more electrons that I need to fill, so I'm just going to put 1, 2. How many valence electrons do I have in an atom of magnesium? I have 2 valence electrons. Really, I'm just looking at that outer ring of electrons to know that answer. Let's try another example. Let's say we were doing something like sulfur. Sulfur has 16 electrons. Again, I'm going to start with my first energy level, and I have 2 electrons in that energy level. In the second energy level, second row, if I count across from lithium to neon, I have 8. So I've got 2, 4, 6, 8. And now I'm in the third energy level, and I have 1, 2, 3, 4, 5, 6 electrons that I have to add in that energy level. So I'm just going to go ahead and do that. 1, 2, 3, 4, 5, 6. And again, my valence shell is that outer energy level. So I have 6 total electrons in that valence shell. And so sulfur will have 6 valence electrons. All right, let's try one more. Let's look at an element that's not necessarily as simple. Let's look at the element iron. So it has 26 protons, 26 electrons. Again, I'm going to follow that simple pattern. Row 1 is going to have 2 electrons. Row 2 is going to have 8 electrons. Row 3 has a total of 8 from sodium to argon, so I'm going to add 8 electrons in on row 3. Then I get to row 4, and row 4 has 1, 2 electrons in it, so I'm going to add 1, 2 electrons. And now I have to jump back to energy level 3. Those transition metals make it a little bit more tricky. So I have to go back to the third ring, and I'm going to add 1, 2, 3, 4, 5, 6 more electrons to that third energy level. So again, going back, I'm going to add 1, 2, 3, 4, 5, 6 electrons. When I'm looking at my valence shell, though, I'm still looking at the highest energy level or furthest away from the nucleus that has dots in it or electrons in it. And right here is my valence shell. I have 1, 2 valence electrons. So iron, while it has a lot of stuff on the inside, still only has 2 electrons on its outside shell, its valence shell.